We'll be explaining about the required documents and the process of preparation of complete building stone mining plan and its documentation as well as the AutoCAD related plans also will be covered in this video. So first we required the required documents are notified sketch and a notification letter issued from Department of Mines and Geology. Then NOCs from various departments include forest, revenue, DC, etc. And we need the land conversion certificate also if it is a patta land. Then we will be in need of drone survey report that we will be doing the survey of the applied area. Then the data will be processed for the extraction of contours, and based on that we will be starting the AutoCAD related drawings. And also in the after the drone and DGPS survey, the DGPS survey readings, which is in line with the notification sketch, using that we will be preparing the KML of the quarry area. Then starting with the AutoCAD drawings, in the AutoCAD we will be covering mainly surface plan, geological sections, production and development plan, production and development section, then conceptual plan, environmental plan, and as well as progressive mine closure plan. That in detail I will be explaining. Once we generated the KML in the Google Earth, after matching with the extent, we will be taking the data into the AutoCAD and starting with the AutoCAD related plans. So in this case, I have considered a building plan preparation of Raichur district. Here, this pink polygon, which is indicating the quarry area, and the nearby survey number is also mentioned in this. Then when we are starting with the first plan, that is surface plan, which will be the inclusion of all the surface features of that quarry area. Here in this plan, the outside boundary, the red boundary, which is indicating the quarry boundary, and the blue, which is given based on the 7.5 buffer from the quarry boundary. And here an approach road as per the ortho image, which is generated after the survey data, or as per the Google Earth, we will be showing the approach road to the quarry. And the contour values are also shown. These contours are generated after the drone survey, and the values of the contours value will be displayed, as well as the boundary points, that is A, B, C, D, also will be added in the surface plan. And here the benchmark, the permanent benchmark of that area will be which is noted down during the survey, that also will be added. That is about the surface plan. Then moving to the geology plan, which is in detail, it is showing the subsurface geological feature also. In the surface plan, we will be adding the details of the mineral availability. That is in this case, the blue plus symbol, that is indicating the building stone availability, which is subsurface area, and also the topsoil, which is on the surface, almost 1 or 2 meter surface, topsoil also will be showing in the geological plan. And here the cross section, that is along the longitudinal LL dash, we have considered, as well as through the widthwise also another cross section, that is AA dash. And since the LL dash, which is the longitudinal section, which is covering almost the entire lengthwise of this quarry area, based on that, we will be proceeding with the cross section. Here, this is the cross section, which has drawn along the LL dash direction. That is, in this case, it is from west to east direction. And in the cross sectional view, we can able to see x-axis, y-axis. In the y-axis, we will be mentioning the RLs, which is based on the contours values of that area. And in the x-axis, it is mentioned the distance from the quarry boundary to the another side of the boundary, that is along the LL dash. And here the green and yellow line indicating the probable reserve limit as well as the proven resource availability. And here, as I already informed, the red boundary is the quarry boundary, and the either blue lines which are indicating the 7.5 buffer. And here, this is the slope, quarry slope, which is almost 45-degree with respect to the quarry surface by providing the 6 by 3 standard bench uh, dimensions, that is 6 meter height as well as the 3 meter width. We will be getting the slope. And here in this case, this reserve, the yellow line which is indicating the proven, up to this it is mineable area, and below to that it is probable area. And here a dash also we have shown along the widthwise of this particular area. And another thing here to be noted is the depth we have considered for this particular uh, quarry area. So here we have considered from the surface till the pit limit, that is till 440 to the 485. It is almost 10, 20, 30, 40, 45 meter depth we have considered. It is for the total extent of 6 acre 21 gundas. Now I'll be explaining about the reserve calculation, that is geological as well as mineable reserve calculation, as well as the year-wise production development of this 6 acre 21 gundas quarry area. First one, coming to the category-wise reserve of calculation, that is the geological total, the mineral reserve calculation of the area. So here comes. So first one about the geological reserve calculation. Here in the table, we are considering the first column, which is the sectional area, sectional influence, then volume, then ROM, which is in tons, then saleable building stone, what is the recovery percentage will be mentioned here, and the rest will be the intercalated waste. In this case, it is 5%. Starting with the sectional area. In this sectional area, in the case of geological reserve, we will be considering the total reserve availability till the proven area. That is, here in this case, the total from this within the quarry boundary, total from total area within the quarry boundary up to the proven limit, that will be considering as the sectional area in the case of geological reserve. Then we will be calculating the sectional influence. Sectional influence we will be calculating by considering the total area divided by the cross sectional length. That is, in this case, 6 acre 21 gundas, that will be converted into square meters, then divided by this 223, that is a cross sectional length. We will be getting the sectional influence. Then multiplied with sectional area and sectional influence, we'll be getting the volume. Multiplying the volume with the specific gravity, that is 2.63 tons per cubic meter, we will be getting the total tons. Out of this total, 95% will be considered as the saleable, and the 5% will be considered as the intercalated waste. Then coming to the probable reserve of geological reserve. For that, in between the proven area, I mean the proven as well as the probable, will be considering for the probable reserve. That is in between the proven and probable. This much square meter will be considered as the sectional area. Then multiplying with the sectional influence and volume, then ROM, then 95% saleable, and as well as the intercalated waste. And we will be summing up the proven and probable for the entire reserve calculation of the geology. Then coming to the mineable reserve calculation. Here again, coming to the CAD in order to check the mineable reserve, that is, here we will be considering after leaving the buffer, how much will be the reserve available in the mineable reserve Here, this much will be the sectional area we need to consider for the mineable reserve calculation by leaving the buffer and the safety slope area. This much square meter multiplied by 97.69. That is by reducing the buffer zone on either side. That is 7.5 on either side. It will become 15. So we'll be multiplying with this, we'll be getting the volume, then converting to tons. Then, as I mentioned earlier, 95 percentage of the total ROM will be the mineable, saleable building stone. Then 5 percentage of that will be the intercalated waste. Then probable reserve, that is here we will be by leaving the buffer and the slope, the safety slope area, we will be considering in between the proven area and the probable. This much will be the mineable probable reserve, that is this blue hatched portion that will be considered here. Then the calculation method is same in the case of other reserve calculation, that is multiplying with the influence. We will be getting the volume, then ROM, then 95 percentage and 5 percentage, and summing up of all this. Then coming to the production and development. So in this case, based on the material availability as well as the quality of the material, we are providing 65 tons of material per annum can be excavated. And here the entire area will be divided for the to the for total 5 years. We will be getting the each per annum how much area can be considered, multiplied with the sectional influence. We will be getting the volume, then converting that into the tonnage, and 95 percentage of that will be the saleable, and the 5 percentage will be the intercalated waste. So in the total 5 years, in this case, 3,42,105 tons will be the total ROM. In that, 3,25,000 will be considered as a saleable building stone, and 17,105 tons will be the total intercalated waste for the 5 years plan period in this case. Now coming to the production development plan. Here in the production and development plan, we will be starting with the bench-wise sections. Here I have considered 6 by 3 benches. In this case, 2 benches are coming for the total 5 years of plan period. The blue hatches, which is indicating the first year, that is here again it is based on the Excel. Here I have already calculated what is a per annum square meter. I have to sectional area I have to consider for 65,000 tons of excavation. So for each year I will be considering 266.31 sectional area here, that I will be measuring for after creation of 2 benches, and I will be dividing these complete benches for each per annum by considering 266.31 square meters. So based on that, I have given hatches for each sections here. This section which is indicating the first year, and green hatch which is indicating the second year, then third year, then starting with the fourth year, then coming to the fifth year. So here after generation of these 2 benches, then we are moving into the next plan, that is then the plan view of production and cross section will be looking like this. Here we are showing an extra hatch which is showing the subsurface mineable reserve availability, which is leaving the buffer area. And here the benches will be indicating, as I have given color for the first year I have given light blue color, so which is starting from the quarry boundary to almost 60-meter distance from the one side of the quarry boundary. So that same distance I will be plotting here to show the first year plan. So from quarry boundary to 60-meter length I will be considering. Till there I will be showing the first year bench. Then continuing with the second year bench, that is from this end to this end I will be measuring. That is from 60 nearby distance to almost 135, which is covering for second year. second year, which is showing with the green color hatch here. Then continuing with the third year, then only little portion of the fourth year I will be starting in the first year bench, I mean first bench, then continuing to the second bench for the continuation of fourth year. That is how it is shown here. Fourth year will be starting in the first bench, then continuing for the further quantity to the second bench. Then the rest of the portion will be excavation of the fifth year. And here the RL is also mentioned. That is, first year we will be starting with the surface level, that is 479. Then again by the second, I mean second bench will be ending in the height of 476 from the surface. That is here almost we are from the surface, including the topsoil, almost it is 9 to 10 meters will be covering for the 5-year plan in this case. And here in the plan view also indicating or giving the information about the plantation in the buffer zone area. Moving to the progressive mine closure. Here the same plan view will be considering for the further stage. Here the infrastructure in the buffer zone will be provided, and here the dump of waste with a retaining wall which is added, and this blue hatch which is indicating the topsoil yard, and this is the mineral yard where the material will be excavated and kept it until the transportation happens. And here an extra highlight will be showing for the buffer zone area. And after the within the mine closure plan, we will be preparing the land use of this area for the next 5 years plan. That is, we are considering the area for each category. That is, for mining, 5 acre and 9 gundas will be considering based on the calculation from the CAD. And for road, for dump yard and infrastructure, mineral storage and topsoil, we are considering total 6 gundas, and safety zone, which will be 1 acre 6 gundas, and total will be the 6 acre 21. It is indicating how we are considering the total quarry area for different land use purposes. Then moving to the environmental management plan. Here the quarry area, from the quarry area, the 500-meter buffer we will be considering to include all the environmental related features of that area. Here in this case, this particular hatch which is indicating a nearby quarry area, and this hatch which is indicating a nearby crusher zone area. And other than that, all other environmental features also will be added here. This yellow hatches which is indicating the total stony area of the part which can be seen through the Google Earth or through the survey data. And this is indicating the grassland area. And here an approach road we are considered to which the plantation should be done. That also will be indicating in the environmental and management plan. And also we can see the RLs of condos within the 500-meter buffer. This plan, which is giving details about the conceptual plan, that is at the end of the quarry, what is the total depth we will be reaching, and what is our final reclamation proposal for this particular quarry. So here the ultimate pit will be at 440-meter level. That in the beginning, as I said, here up to the proven a reserve calculation we have done up to the 440. So here up to this is the ultimate pit limit in this case. That the same we will be showing the last bench up to the 440-meter depth by considering 6/3 benches. And here come the conceptual cross section. Here we are proposing up to the depth of ultimate pit irrigation pond we are proposing, and this here we are also adding the total limit or pit limit at the end of the fifth year. That is, as I said already, 10 meter from the surface in this case we are considered. And here this will be the final A3 layout output of the plan works. Here the surface plan, which is also added with the DGPS survey readings, as well as all the details about the what are the legends. I mean, what are the different symbols we are used and explanation of that, and the quarry details. Then geological plan, geological cross section, and the mineable production plan, then coming to the production and development section, and then coming to the progressive mine closure plan and environmental plan. Then we have the conceptual plan and conceptual cross section. And the very beginning, we have to add the topo sheet or key plan, we will be calling generally, which is downloaded from Survey of India and which will be processed in the GIS. And from the quarry, we are considered 5 kilometer buffer and showing the complete topographical features available in and around the quarry area. And here we are also mentioning in the presence of any national park or wildlife presence within the 5 kilometer boundary of the quarry area. Now coming to the complete mining plan report in the of the building stone and limestone quarry. Basically, a building stone quarry plan is broadly having four parts in the general details, then part A, part B, and part C. The general section, which is having all the details about the applicant and as well as the quarry area. And then coming to the part A will be giving details about the geology, reserve estimation, and quarrying operation, etc. Part B, which will be explaining about the environmental management plan to minimize the impact of quarrying on the surrounding environment. And finally, part C, which will be dealing with the progressive quarry closure plan, which describes how the quarry will be reclaimed and managed after mining is completed. So here I will RQP certificate need to be added, then a certificate by the applicant, then starting with the general mm, content of this quarry area, which as I already informed, the quarry details and what is the total extent, survey numbers, village, taluk, then what is the per annum we are proposing, and the relevant NOCs from forest and revenue, etc. will be added in the general portion. Then coming to the part A, which is about the technical details about the quarry, which also covers the geological details and stratigraphy of the area based on the field observation. What is the how much is the topsoil and what is the general geology of that area, and regional geology, which is here the stratigraphic sequence also I have added, means what is the host rock of that area, country rock, and if there is any major intrusions like dolerite or other rock quartz veins, such intrusions are happened, that details will be explained in the part A geology portion. Then quarry geology, or the local the quarry area, what is the main geology or stratigraphy of that portion. Based on the field observation, we have to add the details here. Then coming to the reserve calculation, as I already covered this reserve calculation, the first table which is indicating the geological reserve, the second portion it is the mineable reserve. Then coming to the quarrying, what is the type of quarrying method, whether it is fully mechanized or semi-mechanized, such details will be added here. Then the production development, that is per annum, how much we are proposing for 5-year plan for this particular case. And then coming to the extent of mechanization, how many machines will be proposed for this particular per annum production, that is 65,000 per annum. So how many excavator, tippers, and their specifications will be provided here. And the loading equipment, again detailing of how the calculation of dumpers, excavator, jackhammers, etc. Then coming to the blasting, by considering the environmental parameters, we will be concluding what is the type of blasting to be adopted here. If it is away from public structures, that is 200 meter as per the guidelines, normal blasting can be proposed, or else it has to go with the controlled blasting or other methods of blasting to be decided in such cases. So here in the blasting, the license details and how the powder factor will be calculated, such details will be included here, and what is how many number of holes to be required, and what is the minimum distance between each hole. Such a calculation will be done here. Then quarry drainage with respect to the groundwater depth of that area, whether say if it is 100 meter from the surface, our in our case it is the from the surface it is to the ultimate pit is we have almost a 45 to 50 meter depth we considered. But in Raichur area, as we know, it is the rainwater I mean groundwater water table will be almost more than 100 meter below. So in this case, it is not nowhere. It is at the ultimate pit. It is nowhere encountering the groundwater table. And then coming to the quarry reject as well as the disposal of waste, we have to mention what is the total topsoil we have considered, the depth based on our field survey, and what is the total tonnage of waste to be included here. And employment calculation also will be adding in the part A. Then coming to the part B, which is giving details about the environmental protection measures during the quarry operation. It will be covering about the air and water and noise quality, flora and fauna, environmental impacts, and what are the mitigation measures or afforestation program, and also about the waste management, and occupational health and safety, and how the environmental monitoring we have proposed. These are the details will be covered in the part B. Then coming to the part C, which is detailing about the how the quarry will be managed after the completion of mining activities, which are also indicating the closure objectives, what are the land reclamation, rehabilitation, and other water management, water wastewater disposal, and financial assurance, what are the other post mining land use, or how the land will be utilized as for irrigation pond or fish pond, like that, how it will be utilized after the closure. This section also ensures the quarry area is restored in a safe and beneficial manner after the mineral resources are exhausted. These are the details we'll be covering in the part C portion, and will be added with all the annexures, all the other relevant documents which is related to this quarry documentation. Then and we will be winding up the quarry plan by adding all the AutoCAD generated uh, plans. And once the quarry plan is completed, it will be handing over to the client. Client will be submitting to the concerned district department for the approval. Once it is approved, then we will be the client will be submitting us back with the quarry plan for the process related to the EC clearance. Then that also we will be taking up, and this is about the complete quarry plan. Here the explanation is giving from RQP Sri Kumari from Parivesh Environmental Engineering. Thank you, sir.